muted.
Good evening and good morning, depending on the geographies that you are in. And so we start our presentation, and also it would be followed by any questions that you have. So you can ask questions if you want in the end. And so, just give me a moment. Let me see if my deck is right. Right. Just a moment. Okay. So thank you. So the topic for today would be that we'll be talking about artificial intelligence and machine learning for business. The broad topic would be artificial intelligence for business, right? So this is the course that is launched by Collabra. So I'll take you through the business, this course, that what does it mean and how is it different from the other courses that we have. And if you have questions like in them, you can always ask, right? So before I probably start, let me probably introduce myself. My name is Amit Saraswat. Basically, I'm an electrical engineer from one of the IITs, and I have worked in companies like Tata Motors. That's a big commercial vehicle company here. Then I have worked with the US healthcare. Uh, just give me a moment, please. Just one moment. I'm hearing some background noise, so I request that they do not make that. Sorry for that. So yeah, so my name is Amit Saraswat, and let me repeat it again. And basically, I'm an electrical engineer from one of the IITs here. I started with started my career with Tata Motors, which is the largest company here in the commercial vehicle segment and also into the passenger vehicle segment. And I worked in other industries such as the US healthcare. I worked in the financial industry here. So that means I have experience across majorly three kind of industries. That is automobiles, then US healthcare industry. Then currently I'm working with the finance industry into the commercial lending. So the finance industry, and I worked. I'll not say too much in that, but a little bit into the FMCG company also, FMCG sector also. That is the fast-moving consumer goods. So, and basically I hold a PhD degree in machine learning, and also I'm a visiting faculty to many leading universities in India, and interacting with students has been my hobby, and I've done a lot of trainings also for leading companies like IBM. I've done it for Cognizant, and I'm on the board of Vodafone for guiding their machine learning efforts and all those things. So so what I mean to say is that I have a total of 21 years of experience. Out of that, 15 years is into machine learning, and that is and I've been associated with business, and I've also equally been passionate about teaching and training also. So whatever I'm discussing today, or whatever course that we have put forward for you, is taking all those things into account. I've taken probably all my experience into account, and then we have come up with this course. So now, without much ado, I'll just start with a small slide here. So this small cartoon which says that, okay, so artificial intelligence, people say that someday artificial intelligence would be so developed that it's going to overrule the human beings, right? Some of partially that may be correct, but those fears are not true, I mean. So a cartoon here which says that, okay, which is the car is recommending a person where to go, where not to go, right? And it's a self-driving car, so you cannot do anything about it. You're on the mercy of the car, right? So probably someday artificial intelligence is going to become become so strong. No doubt about it, it's like making a lot of strides and a lot of improvements are happening. And similar thing here. So I mean, these are the cartoons and the light part of it apart. But AI is a big deal, right? And a lot of things are happening into this area. So before like I start on the contents, let me also and there, because there are a lot of let's say definitions which are floating around on artificial intelligence, machine learning, deep learning. So I just put a common kind of, let's say, relationship between them. So AI happens to be the superset, machine learning happens to be the subset of the AI, artificial intelligence, and deep learning is one of the techniques which is involved into ML. So this is the kind of, let's say, relationship between them. So when I say AI, I generally mean the capability, and when we talk of AI in the context of business, what I mean is using machine learning for the context of business, right? So using machine learning, making it, and the biggest, let's say, objective or the single objective of AI is to make machines as intelligent as human beings, right? Artificial intelligence, to introduce some intelligence out there. So machine learning algorithms can do a monolithic kind of job. That means if I run a classification job, it can do a particular job, that's all. And if the situation changes, then probably the algorithm fails, that's all. And you have to retrain the machine. A retraining has to be done, and probably then it will work better. And if you are working in multiple kind of, let's say, scenarios, then what happens? You need to have multiple algorithms, right? So when we talk of machine learning, then it gives us capability to make the machine learn on the data that we provide. But artificial intelligence gives us more capability beyond this, and that is in terms of that it becomes, or the business becomes capable of automatic decisioning, right? So a big part of like the cases that we'll discuss in this course would be focused around like how to make automatic decisioning possible. So how can we make automatic decisioning possible? What kind of machine learning algorithms to use? And the entire thing may not be achieved through machine learning. There are other things that have to be built around the machine learning thing. Then only the objective can be achieved, right? So next, what I do is let me take you through what does the course offer. What is the kind of thoughts that we have put through in the course. Right now, just one thing I like to mention. Right now, I'm not taking any questions in between. I'm seeing some questions there. I've seen some hands that are raised. But knowingly, like, let me finish off the presentation deck. You can just note wherever you have questions, and in the end, I'll give you enough time to ask me questions. So let me discuss like what does the course actually offer. So the content, this is a broad thing that I put. The content should be data representation. It starts with data representation. How do you represent data? Not necessarily, like example, in let's say we have prescriptions which are coming from doctors, right? The clinical side of EHR or electronic health records. Now, what do we do with that? How do we represent that data? People, generally the advice is that this unstructured data should be, let's say, converted into structured data. So how do we, what does that unstructured data mean? How do we represent it? And then when we provide a structure to it, then what does that mean? So data representation becomes very, very important. Or let's say we are capturing around 10,000 variables. In my current company also, we are like capturing around 10,000 variables. And then what will happen out of these 10,000 variables? More than 50% will have, let's say, data which would be less than 10%. So how do we represent all that, right? So representation becomes very, very important. Typically, when we have large data, when we have unstructured data and all those things. So what could be the methods? What could be an ideal thing to do for this data representation? And tools also behave differently with the way we feed them data, right? So data representation becomes very, very important. Then the second thing is, many of you may be familiar with this, the statistical analysis part of it. Like, what does statistical analysis mean? What value does statistical analysis hold in a business context? That we are going to discuss. Third thing would be about machine learning. So what is machine learning? The different tools, skills that are like needed within that machine learning paradigm. And with this, then we'll move on to artificial intelligence. What does it mean? How does it play a role? So a lot of time will be focused on artificial intelligence, and of course all this would be through lot of case studies. We'll actually bring live case studies. Because I myself have been associated with a lot of industries, plus Collabora has a very good base as far as like companies and industries are concerned. So a lot of data from different aspects is available. So this would be generally through case studies. So the major thing that we'll focus on, like example, is fundamentals of machine learning. Now, talking about how does this course typically differentiate itself from other courses is, generally what happens is the courses that you see are either too much on machine learning, uh, theoretical machine learning, and the business applications are generally missing, or they are too much on just, let's say, the classification or those algorithms. They are too much of algorithm driven, and then people don't know that and generally the kind of, let's say, impression that is provided is that if you know a few algorithms, probably you can solve business problem. It doesn't work that way, right? So what happens, what are the limitations to algorithms, why they work, why they don't work, right? All those things. So fundamentals of machine learning, example, principle of bias and variance. You may get a very good output in terms of, let's say, classification accuracy, or a very low RMSE, that is root mean square error. So your errors may be very low, everything may be fine, but the major question is it generalizable? That means on whatever data, historical data that you have, we are getting good results, but it is going to hold in the future also. So that part is known as generalization. So how do we ensure whatever results we have are going to generalize, right? History repeats in a long run, but it may not repeat in a short run. So principles of bias and variance. Boosting, if you have smaller data sets, right, then how do we use that data set? So the idea of boosting, bagging, all modern algorithms generally use this principle of bagging. Regression or probably classification algorithms use this concept of bagging. Then principles of learning. How do machines learn? What are the principles that we need to keep in mind when we are like teaching machines, making the machines learn? Then we go to errors. What do we understand when we say errors, right? A error in one scenario may not be error in the other scenario, right? So we try to understand what are errors, one. The second thing is how do we measure them? The third thing is how do we take care of them if they are like, if they become a worrisome component. So how do we take care of errors, right? Then outliers, different methods of dealing with outliers. What could be a good method, a rounded approach on different kind of data sets which might work for outliers, right? So the outliers thing. So these are all, but this is just a brief overview of the machine learning fundamentals. But the basic idea, when I started that, I said the deliverables are that the participant should be business ready. Many of you may be already be working with the business, but then what and why probably you have come here to probably hone your skills. I've been a part of other online courses also in the past, but what I see clearly probably missing there is that the focus on participants is probably missing. I mean, the courses don't try to make them business ready. They don't try to anticipate if a person is coming from a particular kind of industry, what are the kind of problems that he may be facing with, and probably how can he deal with them effectively. So we try to address all these things through case studies and individual interactions. Uh, the first step in machine learning or AI is always to understand a business situation and to provide a solution, right? So to translate a business problem into a machine learning problem, that is one of the biggest challenge that is faced by people, right? So how do we do that in scenarios? So we'll make you do that through case studies. And in the concept, so what I'm saying is that we'll try to use the concept of case studies rather than just like giving lectures and being too theoretical, or giving you examples with some data sets which may probably be relevant or irrelevant to you. So we'll try to use the concept of case studies, and the concept of case studies is very, very, let's say, successful in the management studies. So we'll try to use the case study approach to our teaching. The tools. Now, this is one of the highlights of our course is that we'll not depend on a single tool, right? So we'll deliver this course using R, Python, and SAS. When I say SAS, then all the components of SAS. That means base SAS, which is more of programming based. Then enterprise minor, which is a GUI based kind of thing, but requires a lot of knowledge of machine learning algorithms. Enterprise guide, which is for light users, people typically who are skilled only till regression generally use, and or people who want to do factor analysis are people like who use enterprise guide, right? And if you look at these three tools, they combined cover 85% of the market, right? So the basic idea is that you are well covered on the tool side, you are well covered on the learning side, and that covers around 85% of the things that are happening in the market. So you can so we can like address 85% of the market through this. Python is one of the leading languages these days. R follows after that, and SAS is probably on the enterprise level. If you see, there are many industries where like SAS is a must, right? So example, US FDA does not agree or does not accept any results on the clinical side if they are not, let's say, derived using SAS. So SAS is also an important player in many industries. So that's why like this concise kind of effort to introduce R, Python, and SAS. Many of you may not have a programming. Now the question could be like, do participants require a very strong programming kind of background? So my answer would be no, you don't require a very strong background in programming. You don't require a background at all, right? And R, Python, and SAS, all of them are higher level languages, programming languages. That means they are almost English-like, and you even do not need to remember the syntax also, because there are two methods. So I also don't remember many syntaxes and commands at time. There are two sources that probably are available. One, you have lot of let's say almost all the codes are either available in their knowledge repositories, or they are available on lot of blogs, internet, everywhere they are available, and whatever you use, you can make simple, let's say, notepads, and you can copy those commands on a notepad, carry with those codes with you very easily, and use them wherever you require, right? So that's not a big deal, and no background will be required as far as programming is required, right? So now that's the tool. So we are very well covered on the tools. I mean, we are covering the three leading tools in the market: R, Python, and SAS. Then pedagogy, like how do we deliver this course? It would be through lectures. Use cases are a must. We'll show you actual use cases. If you are coding and if there is a problem, you want to, like, the codes are not working, or you want to understand what could be a better code, we'll provide you code help. So you can just, we'll provide you a space where you can just put your codes and the objective. Data, if you can share it, then we'll provide you help on that also, right? Assignments would be given, so that probably you work on them, work with us, right? And all the assignments, there would be individual feedbacks that would be provided. And of course, we'll have a lot of fun when we are going through the course. That's very important. Now let's see, like, generally what are the issues that are faced by business. Let's say people talk about this data pyramid. All of you would have probably seen this data pyramid. So everything starts with data, right? So people say that once we have data, that may not be useful in itself, right? So data, there has to be something done, some processing that has to be done to, let's say, cull out some information out of it. So data plus context is information, right? And further, if you keep on, let's say, mastering that information, and if you keep on using it for business benefit, then it is said that a business has acquired knowledge out of it. So it's like information plus the business rules are extracted out of it. So information combined with some rules becomes knowledge, and then the knowledge that we keep on using over a very long period of time becomes wisdom. That is, knowledge plus experience becomes wisdom. Some examples are given, probably all of you, many of you would rather know about it. Example, how many units sold to a product line is data. Now what is the lowest selling product is information. What made it that unsuccessful, some reason, some rule to it, is the knowledge part of it. But wisdom is what can we do about it, right? So that's the part of it. Or if you look at it, then people have translated the same pyramid in the context of analytics into something they call it that the analytics itself has three phases. That is descriptive, right? So descriptive is nothing but it is more about, let's say, something between on the interface of data and information. Then they say the descriptive then translated into predictive. Predictive is a better skill that can be possessed by business. So predictive is nothing but it is something that lies on the boundary of knowledge and information capabilities. And then people talk about having prescriptive analytics. So people, what it means is that the business is able to identify what can go wrong, right? And we are able to identify it much before in advance. Not only that, but we are able to know what action to take. So what action to take so that we want to change a particular situation in future. So that's the wisdom part of it. Right? So typically, if you look at that descriptive, predictive, and prescriptive hierarchy there, it's very, very strongly related to this data pyramid, right? So looks easy when we write it, but there is a problem here, and the problem is that it's very easier said than done, because what does information mean? How do we define information? Let's say if we have 50 variables, we can have a lot of information out of it. Even if you simply run the means, standard deviation, and simple, let's say, things such as distribution and all those things, there's a lot of information that can be culled out of it, right? Now the issue is from an analytics perspective, this is good that we have generated so much information, but from a business perspective, the question is, what do they require? Is it actually useful or not? Similarly, like when you go from information, you do a lot of predictive analysis, then probably again lot of things are available, but the question is what will be useful for business. And the other thing is, if you change a variable, typically in classification it is said that if you change the data by 3%, that's all. If you change the data by 3% for any chance, the results are bound to change. So what do we do in these scenarios? One, of course, knowing the right skills. That is one part, and the other part that is very, very important, as I said, and that's what we want to focus on, is how do we acquire the capabilities of understanding that whatever we are doing is actually generalizable, it is correct, and will hold in many scenarios in the future also, right? So how do we do that? That's very, very important, and that's one of the USPs of this course. So the course objective, I mean, out of this fill out two, there, as I said, that there are a lot of academic data scientists which are being churned out by a lot of training courses which are available online or offline, institutes, all of them. Due regards and respects to everybody, but they are all academic data scientists. That's what I do, because I am leading a large team. I have 20 data scientists, and most of them have either PhDs or they come from premium institutes like IITs. So this is more like I'm putting based on, let's say, my experience. So they are like more of academic data scientists. They know how to run a classification thing very, very well. But practicing, it needs a lot of practice and guidance also to become a practicing data scientist. So can we like bridge that gap between just turning out purely academic data scientists to like having practicing data scientists, and ultimately having people who can deliver value rather than deliver algorithms, right? So algorithms with the context and how do they understand that what is the value, first identifying value and then delivering that value. So that is one of these are the most important objectives. And of course the other secondary objectives are to make you learn algorithms and to use them on a wide range of data. And generally, like what is happening in the industry is, industry runs through testing lot of hypotheses. Let me give an example. Let's say in a lending industry, somebody says that, okay, without actually doing it, can I simulate a situation where I say that, okay, if I lower my cutoff for score, a bureau score, then what is the kind of impact that I'll see over, let's say, 3 months, 6 month kind of thing? Can I have those kind of answers from analytics and then accordingly act? I mean, once I've lowered it, then definitely I'll get data, and then definitely I can tell this is happening or that is happening. But are we in a position where we can conduct these kind of tests, these kind of hypotheses. We can form these kind of hypotheses and test them without damaging the entire thing. So this is one of the biggest demands that I've seen in the industry. That is what requires. Then whatever our algorithms are, generally they run on some assumptions. Like example, there is an assumption of linearity. At times, when I say there is a probability distribution, the requirement is always that the data should be normally distributed, right? That's one of the distribution. And if you look at, I have a compendium of distributions, and I saw there are 200 distributions there. And I never, like I've gone through lot of data during my, like say, career, but I've never seen any variable which has been normally distributed, right? So outrightly, if you see, these assumptions are violated. So if the assumptions are violated, chances are that there would be some errors which would be introduced in the entire analysis. So how do we understand what is the kind of error that would be introduced, or what do we do to mitigate those kind of errors? So that's again like tying up, saying that academic versus that practical experience that is there. Some, like we'll use lot of use cases that would be derived from these areas, like in whatever I said, probably I'll probably spend few minutes on these areas, and probably like discuss with you like what are the issues, so that you understand that whatever I was saying, what's happening, right? So example, like if you take a use case of let's say a fraud detection models, right? So fraud is generally something that's a very rare kind of event, right? In example, in commercial lending, we always say that 94%, more than 94% people are actually honest. It's only 5 to 6% people who are generally not honest, right? So that means intention fraud. So intention fraud happens only with probably 1 or 2% cases. That's all, not more than that, right? So how do we detect those frauds and all those things? That event itself is very rare, 1% or 2%. And as the data becomes larger, believe me, people may say as the data becomes very large, then probably it becomes very easy, because for everything when I like interact with people, one solution that is universally given is that if there is a large or a big data, things are easy. Believe me, this fraud detection becomes even more difficult, because what happens is these are cases which are in minority, and what happens is with large data, these cases even become more murky, very difficult to identify. So how do we identify? What kind of techniques do we use, right? So how do we filter and come to those kind of cases, and then understand that this is really a fraud? The second example is classification cases, where we have unbalanced percentage of cases. Example, let's say in case of somebody admitted into a hospital, then the propensity of that his whatever insurance that he has bought, probably the insurance that he's carrying will not be like sufficient, or he will not be able to pay. Now these cases, if you look at these cases, generally would be around 10% cases this happens. So 90% cases are okay, but 10% cases are probably these kind of cases. So the data set that we'll have, I mean big or small, whatever, will have let's say a ratio of 90% to 10%, right? Now, how do we classify these things? Because inherently, whatever classifiers that we have, I personally work on around 50 classifiers, right? So all these 50 classifiers, when I work, I've seen they work optimally only when this ratio is at least 25-75%. The ratio of the two classes at least should be, the majority class should minimum should be around 75%, and the minority class should be around 25%, right? If it is a binary kind of classification. So then how do we take care of these kind of things? Now, just to give an example, if you go to literature, there are certain methods which are prescribed. One of them being SMOTE. That's, I mean, if you don't understand it, please don't worry, but I'm just bringing out a case. So there is an algorithm which has been defined in theory, and I've seen a lot of people telling me that they use it. But whenever like I've used it in any of these situations, or I've talked to other colleagues who have tried to use this algorithm, it gives very misleading kind of result. So how do we practically handle these kind of things? How do we handle cases which are like unbalanced in nature? Electronic health records, if you look at it, is a different set of problems. What happens is, generally, if you look at doctors, they at times write abbreviation, right? Just to give an example, pain in the chest, so or they'll write chest pain, anything is possible, right? So on the clinical side, they'll write anything, right? Or very abbreviated kind of things are written. So now how do we use this data and probably use the electronic health records and try to make something known as a clinical decision support system? So when a doctor is prescribing, and as soon as somebody comes out with a complaint, and as soon as the doctor probably types that complaint, can he get a guidance on what could be, let's say, what could be the probable reasons for this complaint, what could be the drugs that would be appropriate, and all those things. Of course, the patient's past history has to be available, the vitals have to be available. So based on the past history, on the vitals, and probably the complaint, can he know like what could be the probable 2-3 reasons of this happening, and what could be the drugs that could be used, and what could be the lab tests that could be done. This is an exciting project of which I am a part. So how do we deal with this kind of data? But as I said, the data there is like a very complex kind of data. And the other thing, the last thing that I like to discuss is something which is automatic decision support systems. This comes from the realm of artificial intelligence. How can I make my systems very intelligent? They can understand a situation and then promptly take a decision. Let me give you a small example to make you understand what do I mean when probably I'm saying automatic decision support system. So let's say there is a customer who is coming and he has a revenue of around let's say 10 million whatever currency annually he has a turnover of 10 million, right? So generally what I'll do is revenue minus whatever is expenses, I'll find out, and then there will be a bureau score and all those things, and based on that I'll give him some loan that is there. Now, but what happens when people come from different industry? Is there impact of that, right? What happens if the business cycles are in a different this thing? Can my models automatically adjust those business cycles, even detect from the data that is available from the internet? Can they detect what is the kind of, let's say, sentiment that is prevailing as far as this business cycles are probably concerned? And then can I have models based on that, right? I can always keep on taking historical data and keep on training my models. That I can always do. But when I'm doing it, I have to understand that when I'm taking historical data and the present situation, the business scenario might have changed. So I'm training a model for a different kind of business cycle altogether, and they may not hold, and this happens too much. So how do I then take the current information and how do I incorporate it to probably do and learn my system? So this is learning. So how do I get my systems updated with the macro environment and have a dynamic kind of learning? So automatic decision support systems are nothing but they'll be majorly based on dynamic learning. So one, learning, we read a lot about learning, the challenges, methods, this and that, everything, right? A lot of methods in learning. But how do we make it dynamic? How do we understand that probably if few things change here and there, then what will be the impact on my models? And how do my models adapt and probably train accordingly? So that is the next thing. So this is broadly like the approach that I'd taken. I'd kept it like short, and or let me specifically tell you the algorithms that we'll be taking you through. We'll be taking you through at least 3 kinds of regression, that is multilinear regression, logistic regression, and probit. So these are the 3 regressions that we'll be taking you through. Classification, we'll be taking you through decision tree based algorithms, which would be boosted, bagging, everything. Then SVM, support vector machines, random forest, or any other algorithm that you feel is very relevant. I'm sure we'll not whatever like or gradient boosted machines, all these things we'll be taking you through. But if you feel that other than this also there is some algorithm which is very good, like example I've seen extreme gradient boosting machines. It has won lot of competitions on Kaggle, so people like want to learn it and use it. So that anyway is just an extension of GBM only, gradient boosted machine. So classification, we are going to cover all this, right? Then we are going to take you through some techniques for unstructured data that will be on the natural language processing side, but that will not be very deep, only few things which may be like probably useful to you that we are going to cover. Then one of the major chunks would be about feature reduction. When I say feature reduction, generally will mean that if you have a lot of variables that I started when I started, I told you, let's say if you have like 5,000 kind of variables, and then you want to reduce it, you want to use only 30 or 50 out of it, then how do you combine variables? What do you do with the data which has only, let's say, 20% data in that? 80% of it is either zero or missing data. So what do you do with such cases where you have 80% kind of missing data, zeros or missing data, whatever it is? So it's sparse kind of data. So how do you handle sparse data? How do you take out value from that? And if you look at the feature reduction techniques, basically they'll come from refer-based methods. So lot of feature reduction methods, probably information value based, mutual information value based. So all those kind of methods we'll be taking you through feature reduction. Then there is something known as dimension reduction also. So dimension reduction, right? Principal component for normal data, principal component for absolutely categorical data. One of the strengths of this course would be, let's say if you have 100% categorical data, right? So let me like just spend 2 minutes to explain what is categorical data. People who know about it may please bear with me. So variables such as, let's say, weight and height, right? They are known as ratio data or scale data. Depending on whatever software you use, you may call it a ratio data or scale data. Why? Because if somebody is 50 kg and the other person is 25 kg, you can very safely say that the person who is 50 kg is 2 times of the person who is probably 25 kg. So the concept of ratios, division, you can use this mathematical operator, division operator there. So that will be the ratio or the scale data. But let's say when you are dealing with categories, example industry, the person comes from a FMCG industry, that the person comes from manufacturing, the person comes from trading. Now these are categories. Now we cannot divide or add a manufacturing with a trading. That doesn't happen. Let's say if your data is entirely categorical, what do you do with that? So one of the strengths of this course would be how do you run a principal component analysis. So let's say you have 200 variables which are absolutely categorical. So how do you run the algorithm? So we'll like be taking you through those algorithms. How do you run those algorithms where you can bring down the number of algorithms from 200 to, let's say, 100 or something like this? So one of the major, let's say, USPs of this course would be to teach you or make you sufficient on the categorical data also. And the truth in business, if you look at it, generally these days the categorical data dominates the ratio data, right? So example income, it's very easy to capture in high, medium, low, rather than asking somebody or capturing the exact value. When we are trying to capture the exact value, chances are that there might be a mistake or people may not answer it correctly, right? And generally when you are asking incomes, you may not ask for a proof because that may lead to business loss, right? So not every variable or not everything can be substantiated by a proof from the customer. Two reasons. One, he may drop off from the service. This could be one, or the other thing could be that he may not have proofs itself, right? It may elongate the TAT or the conversion cycle. So for two reasons, you may just talk to him and then probably just ask. So in those cases, asking exact figures may not be a good idea. But if you ask it, does your income lie between 1 million to 2 million or 0.1 million to, let's say, 1 million, then people are comfortable in answering. And then how do we use this information? This is known as categorical data. So, and this is in abundance in the industry. So how do we actually very effectively use this categorical data for some good use, right? So so this is a well-rounded approach, right? From algorithms, from theory, so the first thing is how do you prepare your data, categorical or otherwise, how do you make sense of your data? That's the first block. The second block is once you have made sense of your data, you have understood the business problem, how do you translate or how do you find out what would be the appropriate algorithm to use? Second thing. The third thing would be whatever outputs you are getting from the algorithms, how do you interpret it, right? So how do you use all the outputs that are given and how do you understand that this algorithm is going to work for a longer period in the future also. It's not a local kind of, let's say, solution that you have given. So your things or whatever optimization has happened, it's not a absolutely local point and may not hold. I mean, it's absolutely sensitive kind of decision. A 5% change in values might lead to a 20% kind of decision in the outcome. So how do you ensure that it's a generalizable thing, generalization? How do you generalize, right? And of course, on the way, like as I said, a large tool set, we'll require a large tool set to do it. So we'll acquire a large tool set, and the overarching objective is to make it like very, very business facing, right? So this is what from our side. What I think they are around, this is around 15-16 minutes which are left, and from the 1 hour that has been given to us. So if there are questions, you may please type in your questions. I'll read out the question, and then probably I'll then take the questions and probably I can answer. So any questions probably? So the questions that are so like Ahmed Fayaz, like so the question is actually, do we provide any online course on this kind of artificial intelligence? This is going to be an online course, and probably once we record it, we'll discuss within us, and probably then we can put it online. That's what we can do here. The other from Arun, the question is, in case of handling sensory data that comes from mic, audio and camera, is there any case for unsupervised? For audio, yes, we have cases, but for the video, we don't have it, Arun, right now. Right? What help, I mean, whatever help you require, Ahmed, in terms of, let's say, because we'll be providing you assignments, as I said, so your assignment help would be there. We'll provide you help in terms of completing your assignment. We'll provide you help in terms of codes, if you have problems in writing codes and all those things, so that all those things definitely we can provide you all those things. Yes, we can. So Sailesh, I think you have an apprehension here where you are saying, can you like cover all these three tools? Sailesh, I've been a part of these kind of courses for last 5 years, and this can be done, right? So don't worry about it. Yes, there would be one thing. Not everybody will master these three tools equally. Some would be very good in one tool and the other they'll know, right? So that is going to happen. So if you come across these tools any point of time, at least you'll be confident about it. You will not be like hesitating in using those tools. At least we'll bring you to that level. And one, so this course will be delivered online, and a certificate would be provided to people. I mean, as I said, there would be assignment and quizzes. So based on that performance. So like Faiz had asked, like a lot of questions coming. I'm trying to take them as quickly as possible. Healthcare service current scenario, Faiz, like artificial intelligence, lot of use cases there. Just let me give you an example. Go to IBM Watson and you'll find that the entire healthcare is moving to artificial intelligence only. Not only this, IBM and Microsoft and Google, the three giants are competing for this space, AI in healthcare. And if you go to Google, you'll get tons of information out there. One example I gave you, clinical decision support system, which is based on AI. Machine learning for mobile apps. Yeah, so mobile apps, yes, definitely. I work very heavily on this mobile apps part of it. So definitely, like we can give you like something there. Mobile apps give us such a rich information. Believe me, people are lending out money just based on app information. That's all. They are not even asking for bank statement. That's the status where this mobile app data has reached. And this question is from Kanak. Kanak, you will be surprised to know there are at least 3 startups out there which are doing very, very good, and they are just analyzing this mobile app data. And personally, I have interacted with them. A list of tools you have shown, sir. Yeah, Mike, what is your question? What about Java? No, Java is not there. Mike, as I said, this is high-level language programming, and please understand this is machine level. So if I Java is something which is more for application programming, and this we are not going to do. Okay. Can I switch from yes, Salish? If your answer is SQL is a good thing to know. I mean, very handy thing to know. And as I said, okay, so again with Sally's question, Sally has asked, can I switch from Unix, PLSQL to DS? One thing, Sally, as I told you, this will not require any kind of background, but also let me qualify when I say this. This is an area which requires lot of patience, lot of hard work. So if you are ready to bring lot of devotion, passion to the table, this is not difficult. So the answer is there. I mean, and that you can ask yourself. So Sweetie has asked, right, what is machine learning, what are its applications? Simple thing, like example, let me give you an example. Without like, let's say, plowing through my data, can my machine tell me that in let's say a retail setting, that there are few products which are being sold less because of, let's say, because I have tied up with inferior kind of brands, I have not positioned them properly. Let's say this could be from the retail side. From the healthcare side, it could be very, very simple. A patient walks in, and as soon as he tells his past history, family history, and he tells his current problem, can the system immediately tell me, probably these are the three reasons, there are three problems that he might have. These would be the drugs would be the best, and this is the only lab test which would be required, right? So this is machine learning. Would like to assignment would be audio analytic engine based application IoT. Yeah, IoT. I think I haven't covered this part, the IoT thing, but Collabora runs one of the best courses in IoT. So whatever machine learning that we are doing, ultimately this all will one of our major focus areas is IoT. We understand that the future lies in IoT. So a lot of IoT things we will be doing. No, so Hitesh, these other than no, market is covered, man. You cannot ask for more, right? So more than enough. What if we have some idea in creating some good thing? Yeah, if you want, we can discuss that offline. We will not do it online because there are two reasons. It will consume somebody else's this thing. I am I consult a lot of companies and I guide a lot of companies. So Ahmed, that's not a problem. Okay, but that would be offline, as I said. Okay. How much time and prerequisite knowledge required? Not like time required is prerequisite, I said not much, but time required would be definitely would be higher. You'll have to be ready to bring in at least 2 to 3 hours every day if you really want to learn it fast and probably come up to a level, right? No, fee structure and all those things, and the duration is probably, we haven't talked about it. I haven't talked about it. The duration I can definitely probably talk about it. Depending on how we do, it would be structured for around 40 to 50 hours, somewhere between 40 to 50 hours. The fee structure probably would be mailed out to you. Right now, that's something that is being discussed. No, I think the course is not free. It's a paid course, and it's not aimed at medical field. That just I've given some examples from the medical field. That's all. But it is aimed at covering wide variety of industries wherever people are working. That's the idea. The other thing could be any kind of thing. It could be retail, it could be FMCG, it could be automobiles, it could be finance, anything. So case studies will come from all industries, at least 6-7 industries, right? At least 7 industries. We'll have 7 in this thing. No, it doesn't cover Apache Spark, Bhupen, because Apache Spark is more of a, let's say, it's more of let's say infrastructure rather than a machine learning or let's say artificial intelligence kind of thing. It is a facility to deal with the, let's say, the big data kind of thing, the big data. So Apache Spark, we are not dealing in that. So if that is required, probably that will be some other course in which we can cover. Otherwise, this will become a very long kind of course, right? So analytics with Apache Spark, we are not doing. What is average package tools are used in banking domain? So banking domain, I mean, it's banking means so many things, right? It means lending, it means so many things. So but generally in banking are highly used. Python also better. So all three are being used in the banking domain. in this brief time, I mean in just 4 5, what do you think will be the, like, Sweetie, very interesting, or every company will be forced to move to machine learning or adopt artificial intelligence, and if if the companies do not adopt this, then probably they'll not be deemed to be good companies. That will impact their services, that will impact things, and that will impact their image also. What about in computer field? I was like computer field, I don't know what does that computer field and robotic thing mean. Robotics, when I say, again, the IoT thing is about its sensor data again. So IoT covers a lot of those things. So in the course in IoT, we are covering a lot of sensor data related analytics. So robotics, I think some part of it would be covered there, but definitely we are not covering robotics in this course specifically. Okay. Application, yeah, Varun, that I said that we'll be providing a course on that. And if you have specific and if you have specific queries, please what I'll do is definitely send them across to the email that would be provided to you, and we can then answer them one by one. That would be a good idea, right? Because the IoT thing and the audio analytic engine is a specific query from Arun. So Arun, probably we can answer it through a mail or something like this specifically for you, right? Deep learning, yes, we are going to cover. Image detection, deep learning, we are going to cover. OCR is not a machine learning problem, so we are going to cover deep learning definitely, right? Artificial intelligence, one of the methods is deep learning, we are going to cover it. A good project, a lot of good projects, right? A lot of good projects are available in and internships. Yes, many companies are taking interns. Probably this we can discuss offline if required. No, it's not a, I mean, Emma, this is not a robotic thing. I mean, it's there's a difference between automatic and robotic. Robotic also requires a lot of mechanical stuff. And here, when we are talking of automation, probably it's a different kind of thing. Probably what is common between robot and this is probably, I don't know if you are talking about a robot which has the capability to probably respond to its environment very well, right? Banks have adopted some robots, but if you look at those robots, they are fed with 120 FAQs maximum. You'll be surprised to know that the banks, there are 120 FAQs through which they can answer 90% of the queries of customers. Okay, so robotics, when we are talking about robotics, this can be the scenario, but artificial intelligence would be much more than that, right? Can we switch to, so Sam, the question is, can we switch to artificial intelligence and get a job in Canada? I'm trying with Canada PR. Every country, as far as I know, Canada, day before yesterday, there was like a discussion in their parliament, and they were discussing methods how Canada as a country can adopt this artificial intelligence and machine learning very fast. So they are contacting and one of the universities of Montreal is actually one of the known places for artificial intelligence. I'll say they are one of the originators of artificial intelligence. So what I think is Canada, there's a lot of things that are happening, but I don't know. I mean, I'm not in a position to comment on the PR and that job kind of thing. But what I can tell you, the macro environment, definitely a lot of things are happening in Canada, and that's being discussed in the parliament. So probably you can understand. Live projects would be there, yes. There'll be live projects only, actual projects. In which side you can learn AI. There are a lot of, like, Coursera has like about AI, and there are some specialized. Stanford has very good material on AI, very nice tutorials on AI. So that would be there. Yeah. Bagging and boosting is like this. Let's say if you run a classifier, I mean, this will become a too long kind of thing. And just like in short, I'm briefing. Bagging and boosting, when do you use it? Let's say you run a classifier and your accuracy is 40%, which is less than tossing a coin. Now what do? So what you do is you use many algorithms, right? And you combine the weak learners and make them probably a strong learner. That is the idea of boosting. Bagging is a different thing. Bagging is when you have less sample, less data available. How do you actually reach to the correct parameters in that? That is known as bagging, right? So bagging, and these are bagging and boosting. This job placement thing, I'm not sure about it, but actually, because I'm more on the instruction part of it, so probably, Tony, what I can do is communicate to you in a day or two. I'm not sure that we have like done anything on it, but Collabora has a lot of, let's say, tie-ups or something, and if they are thinking, definitely we can do something about it. But right now, I'm not committing on anything. anything on it, right? So let me discuss and then probably give a day or 2 days kind of thing, and probably we'll be back to you. Yeah, IoT, like Bhupen, we'll do some use cases. Example, like we'll have some data. Example, the kind of IoT that even Reliance Jio is trying to do. Just for your information, I was heading this BI effort in Reliance Jio. So probably I have an idea like what is happening in IoT and what is not happening there. So we'll discuss some cases. What path to follow for a career? Data science, machine learning. Data science and machine learning probably are just the term. Data science is nothing but machine learning and plus the capability of handling data. So data handling capabilities plus machine learning becomes data science, right? That's why I started with, when I started my slides, I said that we'll also understand about data representation, right? So that's the decision science part of it. Yeah. Well, IoT and AI, that's the future mind, right? IoT and this is the future, I'm telling you. That would be a, I mean, very nice combination. Rather, that would be the only combination that we will have. Yeah, there is a relationship between automation and AI. Nowadays, service automation, I'm talking specifically of service automation, is heavily dependent on AI. Creating a chatbot, not much. Machine learning involved in, yes, there is, but 2-3 algorithms do the trick in chatbot. Not a very difficult technology. Not very, let's say, difficult kind of machine learning is involved. But if you really want to do a very super intelligent kind of thing, then depends on how much intelligent you want to make your chatbot, right? So depending on that, the answer is depending on what level of intelligence you want in that. If you want super intelligence, as I said, yes, lot of machine learning. If you don't want that, then probably some FAQs and a simple machine learning will also do. Okay. How you get this? For this webinar, I mean, for the webinar, we don't get a certificate, Karthik. I mean, we're not giving certificates for the webinar, right? Models or algorithm, like for deep learning, I mean, all convolution neural networks, restricted Boltzmann machines, all those things we are going to cover, Hansen. Yeah, you'll get a detailed information on the course from Collabora, right? Just give a day or two and you'll have detailed information. Yes, data science is a part of AI, Mahesh, right? Why we use, see, I mean, Karthik, there is no answer to these things like list, prologue. I mean, the number of tools that are being used, at least I know of at least 250 tools I have in my collection, right? And the number of softwares, statistical software that I myself use is 12. But I never got an answer why they are being used. The reason is some of them are strong in one of the areas. Let me give you one example. Self-fold predictive modeling, that's a software which has been now bought over by Microsoft. That is one of the wonderful softwares you'll see if you want to run tree-based decision thing, and that's something they're proprietary. So at times what happens, people come with one particular algorithm that is proprietary and they use it. Example, TensorFlow. Now that TensorFlow is very, very useful when you want to do deep learning. And for running deep learning, there are at least 20 leading tools in the market. So probably people will keep on making it. Our job is to select the best and then probably keep on using it. And the same logic would be MATLAB is such a great tool. Why don't we use it? Because engineers definitely are let's say introduced to MATLAB when they are in the engineering courses. But after that, it's difficult, right? I used it a lot when I was in my IITs, but after that I didn't use it much, right? So that is the reason. Is there any type of algorithm? No, I mean, the algorithms are not competing with deep learning. Nutan, please understand, Nutan, it's not that there is a competition between algorithms and deep learning and there would be winners and losers. That's not the case. It's in some cases deep learning is required and in some cases algorithms are good. Also, please let me clarify, deep learning is also algorithms. I mean, who said deep learning are not algorithms? They are also algorithms. There is but that's a specific class of algorithms. Okay. For learning, deep learning, yes, Python is important. That's right. You are right. Yes, Ramchandra, you are right. But R also you can use for deep learning. Python is important, but I'm not saying that you cannot learn it without Python. That's what I'm not saying. Okay. Computer science in third year, like no. People, I think rather if you are in third year of and probably that is the right time you started thinking right now, probably that's a good idea. I'll always say that this machine learning thing should be now introduced in third year in the machine learning is a subset of AI. That's right, sweetie. That's right. Absolutely correct. Yeah. So if you don't have any other questions, and the time that was given is also over. List programming is a niche kind of thing, Mike, required in some places, but not all places. It's a niche, as I said. Okay. So niche, you understand. It's people require it, but it's not a general kind of thing. If I talk about the 85% industry, I don't know that list programming would be very, very useful. But in some places, it's an absolute must, right? So if you know it, I mean, that's a very good thing to know. If you are picking it up as a skill, I'll say please continue doing it. Don't drop it, right? We should not be absolutely going by the market. Yeah, I mean, it becomes more than, I mean, there's a debate, Nutan, that's going on, and probably some people are portraying a doomsday kind of thing, but I'm an optimist. I think it will do more good than bad. I'm sure about it. Gagandeep, I'm 35 plus. Man, what has age to do with like this thing? I didn't understand that. I mean, absolutely. That's all. I mean, age has nothing to do with data science and ag. And probably is it good at switching? There is a huge demand for jobs that is coming up. India, I mean, very frankly, if you look at it, quality people are not available. So people are just recruiting center, left, and right. That is the reason. So there is lot of scope, and that's going to happen. Python is mandatory? No, it's not mandatory, man. It's not Ramjan. It's not mandatory. Right. All AI course which no idea MTech or AMS. I don't see correlations. Very frankly, I don't see correlations between courses and skills. It's more like so two of you, Gagan and Mike, I'll say age and courses do not have correlations. It's the intentions that you bring to the table. This is what I'm saying. And look at me. I mean, do you think that when I did my engineering, I was just 21 years. There was nothing known as data science, man. I picked up after I was 30 plus, because then only data science came, or this machine learning came. So I picked it up when I was 30 plus, because before that this wonderful area was just not available. But I'm one of the first movers. Like when R started, I was one of the initial 10 users in India. Yeah, probably one day, Ahmed, that will happen. One day that will happen. Okay. Yeah. Okay. Okay, Mike. Right. So you'll get the emails and all those things. So where probably you can shoot your questions, and probably I'll definitely answer them. Okay. So okay. So I'll thank all of you for your being very good listeners and asking so many questions. And probably I think it would have been recorded, or no idea. I haven't recorded it, but Avinash, I'll just probably answer you, because I was so busy talking to you, so focused on that, I didn't pay attention whether the, but Avinash, you can definitely send your queries, even if it is not recorded. If it is recorded, then also I don't know if it is not recorded, you can just send a lot of things. Training can be possible in Collabora. I don't know, because that Collabora is I don't belong to Collabora, so it would not be fair to comment on their behalf, right? So those kind of things probably Collabora can probably answer specifically, right? So thank you all for being patient learning. Yeah. You can send your queries as Collabora text, and I'll answer all of them. Yeah, sure, I'll do that, because I want just one place where all the queries should come. So when I'm answering, I'm sure that I'm answering all the queries. Yeah, and anything related to Collabora, like example, all the questions that you had, probably they can answer it. Okay, so thank you all for being nice listeners. Okay, so okay, Alok. So thank you all, and best of luck. Right, and I'm closing the session now. And if you have any queries, please do send mails, and you'll get, I mean, when you send mails, you'll get all this information there, and you'll get everything. Don't worry about it, right? So you'll be in a position to get your queries solved or get future direction. Don't worry about it. Okay. Thank you, Avinash. Thank you all. Bye bye. and best of luck.